Today we'll be working in Chapter 5, Section 1. The chapter is on exponents. So first, let's get a little refresher on what an exponent is. Exponents look like this. You have a base with an exponent power. So x is the base, where n is the exponent. You use exponents in order to shorten up a whole bunch of multiplications. So x to the second power means x times x. This is also read as x squared. X to the third power is x times x times x, and this is also read as x cubed. Those are the only two that really kind of have a special name. So anything to the second power is going to be something squared, anything to the third power is going to be something cubed. So you can keep going. X to the fourth is x times x times x times x. And then you can even have like x to the m power, which means x times x times x times dot 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 times x m times. So you're taking x times itself however many times m is. So let's do an example. We have x, 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 y, y, y. We need to write this using exponents. What you need to do is you need to count. We have 1, 2, 3, 4 x's. So we have x to the fourth, and then 1, 2, 3 y's, y to the third. And that's how you go from long form to exponents. Now when you're working with exponents, there are some different rules. So the first rule we're going to work with is known as the product rule. And I'm going to give you the generic form, and then I'm going to work some examples for you. So this says x to the m times x to the n equals x to the m plus n power. Okay, so let's show you an example so you see what that means. What that means is if you're taking x to the fourth times x to the third power, then that should be the same as x to the fourth plus 3, which equals x to the seventh. The reason that is if you think about x to the fourth, that's x times x times x times x, and then you're timesing that by x to the third, which is x times x times x. So if you're trying to figure that up, you're just going 1, 2, 3, 4, 5, 6, 7, which is x to the seventh, which is the same answer as the one that we just got. So if you're multiplying exponents with the same base, you add the exponents. It's exactly what we just did. So let's do another example. So if we have x times x to the fifth, take x, and there's just one x there, so that's like there's an understood 1. So it's 1 plus 5, which equals x to the sixth. What if we had y to the fourth times y to the seventh? Take y to the fourth plus 7, which equals y to the 11th. Last one, we have 3 to the 5th times 3 to the 4th. Even if it's numbers, you can still leave it in exponential form. So it's 3 to the 5th plus 4 equals 3 to the 9th. So that's the product rule. The product rule states if you're multiplying exponents with the same base, you add the exponents. So if we have a product rule which works with multiplication, then that seems to lead you to think we're going to have a quotient rule. Again, I'm going to give you the generic form first, and then I'll work some examples. We have x to the m over x to the n, and that equals x to the m minus n. So let's do an example over here to the side. We have x to the 4th over x to the 2nd. So what that says is we should have x to the 4 minus 2. Excuse my cat for going around in the background with his bell on. So that leaves us x to the 2nd. Again, you can think about this as we have x times x times x times x over x and x. So remember, we're allowed to cancel things if they're on top and bottom, if they're the same. This means we could cancel 1x, we could cancel 2x's, cancel 2x's. That leaves us with x, which is x squared. Again, we get the same answer. So it just shows that this quotient rule does in fact work. So let's do another one. Example. We have x to the 5th over x to the 9th. So if we're subtracting these, we're going to have 4, but where's the bigger number? The bigger number is on bottom. So that means we're going to have x to the 4th on bottom. Something you're going to learn in section, I'll start that. In 5.2, you will learn about negative exponents. And so that's where you're going to cover this, where if you would have taken x to the 5 minus 9, you would have gotten x to the negative 4, which equals 1 over x to the 4th. So you're going to cover that more in 5.2, but you kind of see it right here when you're doing the quotient rule as well. Okay, after the quotient rule, you have 2 more rules. The first one is pretty much just a simple rule, one that you're going to have to remember, and it's called the zero exponent rule. And the zero exponent rule says if you have an exponent of 0, then it equals 1. And this is when x does not equal 0. Okay, so regardless of what your base is, if it's raised to the 0 power, your answer is 1. So let's look at an example. We have 3 to the 0 power, that equals 1. We have y to the 0 power, that equals 1. Okay, here's kind of a tricky question. We have 3x to the 0 power. Before everybody says 0, we have to look. The only thing that this 0 is connected to is this x. That's it. It's basically like saying 3 times x to the 0 power. So that's 3 times 1, which is 3. So you have to be careful and watch exactly what that exponent is attached to. Okay, that's different than if we would have written it like this, 3x to the 0 power. Now the 3 and the x are both raised to that 0 power, so that equals 1. Okay, let's do one more. We have 4x squared, y to the third, z to the 0. Again, you have to look and see what exactly is attached to that exponent, and it's just that z. So that means we have 4x squared, y to the third, because this went to 1. So we're just left with that. That's all you have to do with the 0 exponent rule, is if you get a 0 power, then that equals 1. The last rule when you're working with exponents is called the power rule. So here's the generic form. It says if we have x to the m and we raise all of that to the n power, then it's the same thing as having x to the m times n power. So this is a little bit different than what we've been doing. This says we're taking an exponent and raising it to another exponent. I'll write that over here. Taking an exponent and raising it to an exponent. Okay, so our example, we have x to the third and we're going to raise that to the fifth. So by our power rule, that means we have x to the third times 5, which equals x to the 15th power. And I'll write this out in a smaller one. Let's do a smaller example and I'll show you why this works this way. If we have x to the second power raised to the second power, that says x2 times 2, which equals x to the fourth. So what that says is we have x squared in here. So we have x, and then we're going to raise that to the second power. So we're going to write everything in here twice. So that would be xx, xx, and if you add up all those x's, you get x to the fourth. So this is why all of that works. So let's do another one. You can do this again with numbers. You can have 3 to the fourth and have all of that raised to the second power. So that's 3 to the fourth times 2. 4 times 2 is 8, so you have 3 to the 8th power. Alright, let's work another example. What if I have 5x squared? Now, we have to look at this. We have to distribute this exponent into everything that's inside of here. So we have to distribute it into the 5, and we have to distribute it into the x. So we have to distribute it into the 5, which will be 5 squared, and we have to distribute it into the x squared. 5 squared is 25, and then you just have your x squared. So let's do another one that's just like that. This is distribute the exponents. Okay, let's do another one. We have 4xy to the fourth power. So we have to distribute it into each one of these. So we have 4 to the fourth, x to the fourth, and y to the fourth. 4 to the fourth, if you type that into your calculator, you get 256. X to the fourth, y to the fourth. Alright, we're going to do a harder version of this. But it's still the same concept. We're still just distributing in the exponents so that we know how to do this. Here's one that's one of the hardest ones you're going to have. Negative 2y over 3z. We're going to raise that to the second power. Okay, so let's distribute that into everything on the inside. So you'd have negative 2 squared. Notice I put that negative 2 in parentheses, and I do that so that you don't lose that negative, because that's something that is very easy to do. So you have negative 2 squared, y squared, 3 squared, and z squared. And the reason I put that negative 2 in there is because now you know that negative 2 squared, it's up here, negative 2 squared equals negative 2 times negative 2, which is positive 4. So that way you don't lose that negative, so that's 4y squared over 9z squared. And we distributed that in, and that is your final answer to that problem. So let's go and look at some of our homework problems. Alright, so let's get your homework open. Remember, it's section 5.1. Alright, so here's the very first problem on your homework. X to the 6 times x to the 4. Notice we are multiplying these, so that means we're going to be doing our product rule. And when you're doing your product rule, that means you're adding your exponents. So x to the 6th plus x to the 4th, that's going to be x to the 10th. Now over here on your side, don't forget about your helpful little buttons. There's this one, which is called a superscript, which is going to be the one you need to use for your exponent problems. Whoops, you need to type in your base first. So you're going to type in x, and then hit that button, and then it'll give you your exponents box, and then you just type in your answer. Hit enter. We got a good job. Let's see what number 2 is. Nope. Go ahead. Here's a quotient rule problem. So quotient rule says we're going to subtract our exponents. So we have x to the 10th over x to the 5th. So 10 minus 5 equals x to the 5th. Good job. I'm trying to find one of these harder problems for you. Alright, here's a good one. Let's do this one. And I'll pull up my screen down here. We can do them side by side. Alright, so we have 5y to the 0. So we have 5y to the 0. This is using our 0 exponent rule. So remember, we have to look and see what is this 0 exponent connected to. It's only connected to that y, so that means all that's going to go to 1. And then the 5 is still out front, so we still have 5 times 1, which equals 5. So our answer should be 5. Let's put that in and see if that is correct. Hey, we did it. You guys are so smart. Alright, let's do this one. I think you guys have it in you. We have 2 times 3d to the 0 power. Again, this is a 0 power rule. We're just looking to see what is the 0 power affecting. And it's affecting this 3 and this d. So that means all of that is going to be turned into a 1. We still have our 2 out front, so we have 2 times 1, and that equals 2. So we get over here, and we click 2, hit enter. We did it. So let's get on to a harder problem. Okay, this is the hardest problem on your whole homework assignment. It's the last problem, so let's work through that one together. Alright. We have negative 4 x to the 6th, all inside the parentheses, and then all of that is raised to the 2nd power. So remember, we have to distribute this power into everything on the inside. So that means we have negative 4 to the 2nd power times x to the 6th to the 2nd power. So let's just focus on the second part right here. This is our power rule. So this says if we have a exponent raised to an exponent, it's right out here, power rule, then we're taking our exponents, multiplying them. So that means we have x to the 6th times 2, which equals x to the 12th. And this one says we have negative 4 to the second power, so that's negative 4 times negative 4. The two negatives make it a positive, and 4 times 4 is 16. So that gives us 16 times, and then we add x to the square, or x to the 12th, excuse me. So that gives us 16 x to the 12th. So let's put that in and see if we get the right answer. We have 16x, and then we have to click our exponent button to the 12th, hit enter, we got it right. Okay, exponents are one of those things that if you get it, then it's nice and easy, and if you don't get it, then there's not a lot of problems obviously on this homework for you to practice on. There's 11 problems, and we had quite a few different rules. So this is where I really strongly suggest using that similar exercise button down here at the bottom. You can hit that button, and look at that, we've got a whole new problem. You work it the same way, but it's got new numbers, so it'll just give you some more practice. So good luck on your homework, good luck on your quizzes.